Okay, this lesson is on geometric sequences. So we'll start by talking about what geometric sequences are. So for a geometric sequence, basically each term is multiplied by the same number. So what I mean by that is, like, the pattern is to multiply by the same number over and over to get the next term. So on our examples, if you look at the first one, it goes 5, 10, 20, 40, 80. What are they multiplying by?
2.
2. Good job. So they're taking it times 2, times 2, times 2, times 2. And that number that you're multiplying by has to be a constant. It is called the common ratio, and for short we're going to use R. So we would say for this one that R equals 2. And they call it a ratio because you could take a number and divide it by the number before to get 2. Sometimes if it's really weird numbers, if you take this divided by this, you'll figure out what they're multiplying by. So on the next one, it doesn't really look like it's multiplying. It looks like it's more dividing by 2, dividing by 2. If we want to think of it as in terms of multiplication, we just use the inverse. So we could think of it as taking it times a half, times a half, times a half. So if it looks like it's dividing, instead of multiplying, it's still the same thing. We're just multiplying by a half or a third or a fourth or whatever. And so on this one, we'd say the common ratio is a half. It does have to be the same number that you're multiplying by all the way across. If it changes somewhere in the middle, then it's not a geometric sequence. Okay, so let's take a look at some examples and we'll identify which ones are and which ones are not a geometric sequence. And then it says if they are, we're going to find the common ratio. So take a look at the first one. Looks like it's pretty much just multiplying by 2 all the way across again, right? So we'll say yes it is, and the ratio is 2. What about the second one? Sometimes it helps to go backwards. 8, 16, 32. So it looks like it is, except it's going down by a half again. So the ratio would be a half. What about the third one? No, it's not even multiplying, really. It kind of looks like, okay, 4 times 2 is 8, but nothing else really fits the pattern, so that's just a big fat no. And then the last one, when they give you fractions, it's a little bit more exciting. You want to look at the top numbers and the bottom numbers separately. So on the top, if we look carefully, it is multiplying by 2. And on the bottom, it is multiplying by 7. And if you weren't sure, you could sit there with a calculator and go, okay, is it 7 all the way across? You could check it. So if the top's being multiplied by 2 and the bottom's being multiplied by 7, it's yes.
R equals 2 over 7.
Yes, exactly right. So it would be R equals 2/7. Cool. So you just have to kind of check. And if you're not sure, you can sit there and play with the numbers on a calculator, like I said. On the fractions, I would play with the top number and the bottom number separately, kind of simplify it for yourself, because that looks a little intimidating at first glance with those big numbers. All right, so just like with the arithmetic sequences, there is a pattern to writing the formula for geometric sequences. So we're going to look at that next. So if you're writing the formula, you have your generic AN term, and it equals the first term times R to the n minus 1 power. So it's a little bizarre, but it works. And I've already written in what these all mean. So AN is just the nth term of the sequence. That's basically the name of your formula. A1 is the first term. N is the number of terms. And R is that common ratio, what you're multiplying by each time. Okay. So if we go in and take a look at examples, it says write out the terms for each sequence. And so let's just go through what it means. So the A1 equals 5 just tells you what the first term is. R is 3, so that tells you what you're multiplying by. And then N equals 4 gives you the number of terms. So this one's pretty straightforward. If we wanted to, we could just take and start, okay, A1 is 5, and n's 4 means that we're going to have 4 terms. So A1's 5, A2, we're multiplying by 3, so it'd be 5 times 3 is 15. A3, I would take the 15 times 3 and get 45. And then on the 4th term, take 45 times 3 and we get 135. And so that would be our first 4 terms. And theoretically, we're supposed to write it out with commas. 5, 15, 45, 135. On the worksheet, there's not a lot of room, so if you just want to box those 4 numbers, I'm okay with that. It's still the first 4 terms. And we'll practice writing the formulas in a little bit. I'm just going to start off with simple stuff. Okay, so if we go down to the next one, it says write out the terms for the sequence. So they give us that the 3rd term is -1. R is 2, so we're multiplying by 2 every time, and they want us to do the first 5 terms. So they kind of started in the middle. So we have to figure out what A1 and A2 are. We know A3 is -1. We know that we're multiplying by 2. So I like to go forward first. So to get the 4th term, I would take -1 times 2, which is -2. And then to get A5, I would take -2 times 2, which is -4. So going backwards, it's a little interesting. So if we think about it, we're multiplying to go forwards. So to go backwards, we'd have to divide. So I would take -1 and divide by 2. So it would just be -1/2. And then if I were to divide by 2 again, I get -1/4. Or you could think of it as being half of a half. Does that make sense?
Yeah.
So that's a way that you can kind of reason through these. When they're giving you lots of information on those, you wouldn't necessarily need a formula. You could just go through and kind of reason through what they are using patterns. We've been using patterns since we were in kindergarten, so some of this kind of comes intuitively. We just have to add a little math to it. Okay, so where the formula comes in is when we want to find not all of the terms, but just a particular one. So on the next one, when it says find AN, that means you're going to write the formula. An explicit formula is what we're going to look at. There's explicit and recursive. We're going to do the explicit. And then the A10 means that they want the 10th term from the sequence. So they've given us the beginning of the sequence, 2, 16, 128, 1024. So I can see that my first term, A1, is 2. We'll need that for our formula. The other part that we need for our formula is what they're multiplying by each time, that common ratio. So what are we multiplying by each time? 8. We're taking it times 8. So R equals 8. So the generic formula that we use is AN equals A1 times R to the n minus 1 power. So if we're going to write the formula, we just put in the first term, which is 2, and then the 8, so times 8 to the n minus 1 power. And something that they often add to this, just to kind of keep these numbers separate, is they will often put the ratio, the R, in parentheses, just so this doesn't accidentally turn into 28 to the n minus 1, because that little times dot doesn't show up. And that's all you do to write the formula. There's not really anything that we have to do to simplify it, so it's a little simpler than yesterday in that regard. So that's the formula that they wanted us to write. And then if they want us to find the 10th term, we just put 10 into the formula. So the 10th term would be 2 times 8 to the 10 minus 1 power. And before you would put that in a calculator, I would go ahead and do the 10 minus 1 and make that 9. And this comes out to be a very large number. It is 2, 6, 8, 4, 3, 5, 4, 5, 6. I'm going to put some commas on that. And it's possible on some of these because the numbers get big because we're multiplying, we're not adding anymore. So when you multiply, some of these are going to get really big. It's possible your calculator will give you some of these answers in scientific notation with the little e. And if it does, we'll just roll with it. I think this one I got off the graphing calculator. The graphing calculators will put a lot of digits in there. But if it gets too big, it may throw out a scientific notation once in a while. Okay, so let's flip over to the next slide. So same thing, they want us to find the formula, they want us to do the 10th term, except we've got fractions. Don't let that scare you, it isn't really that big a deal. So the first thing we have to do is, we know that our formula, an, is a1 times r to the n minus 1 power. So we have to find the first term and r. So the first term, pretty easy, it's 2/5. And then the r, we're going to have to look at the top. So what are we multiplying by on the top? From here to here to here to here. 3. And then what are we multiplying by on the bottom? 5. Just stop my video.